review, and I said again, you know, another way to review would be also to redo the, you know, the tests and quizzes we did. So let's go over. But this comes from the official review right here, right? So this is a rational equation. Okay. So we're gonna try to find the domain, the vertical asymptote, the horizontal asymptote, x-intercept, y-intercept, and then try to sketch a graph, some type of graphs, okay? Knowing that, you know, we really are not equipped, we are not fully equipped to graph exactly the function. At first, what you're gonna try to do is to factor, right? You know, you can leave it like that, you know, okay. But when you factor, it makes it easier to come up to some you know, to solve some problems. Now the domain right here, the domain is always the denominator is not equal to 0, right? That is always going to be the domain. The denominator cannot be equal to 0, which is for the domain here, which is 2x squared minus 18 cannot be equal to 0, right? Which is x squared cannot be equal to 9. So x cannot be equal to plus or minus 3. So that is the domain. X should be different from positive 3 or negative 3. Now, if I write as an interval, it's going to be negative infinity, negative 3, union, negative 3, positive 3, union, positive 3, infinity. Okay, that is a domain. Everybody understand that? For any rational equation, if it is a rational function, the domain is all the numbers except those numbers that make the denominator 0, okay? And from the domain, we can go ahead and say the vertical asymptote are x equal negative 3 and x equal positive 3. Don't forget to put the equals, the x. Don't forget to put the x equal, because we're talking about vertical lines, okay? If we say, like some people do it in test, vertical asymptote is negative 3, positive 3, that is wrong, okay? You have to put x equal. You see that these two lines are my vertical asymptote. This line right here, this line right here. All right. Horizontal asymptote. Okay, can somebody tell me, what do we compare to come up with a horizontal asymptote? We compare what? We compare the
leading coefficients of
leading coefficient if the degrees are
the same.
Are the same, right? And is this, which is the case here? Degree 2, so they are exactly the same. So the horizontal asymptote will be y equals the leading coefficient 5 over 2. Coefficient, I mean the quotient, the division of the two leading coefficient, 5/2, right? Y equals 5/2 is my horizontal asymptote. And again, what that means? It means when you plug in big numbers, when x goes to infinity, the function is very close to 5 over 2. If you plug in 1 million, f of 1 million is very close to 2.5. F of negative 1 million is very close to 2.5. And you can check that out, okay? So 2.5 is right here. This is 5/2. This is y equal 5/2, right? So that is my horizontal asymptote. It means when I plug in big numbers, my function is actually very close to 5.5, 5.2. I mean 5/2, 2.5. Okay, the y-intercept. in the context of a function, what is always y-intercept if it does exist? In the context of a function, the y-intercept is always what?
F of x.
F of what? What
F of
particular x?
x.
No, I mean, what particular x? The y-intercept is always f of
0.
0. Always. If it does exist, okay? Sometimes it doesn't exist if 0 is not in the domain. But if 0 is in the domain, the y-intercept is always f of 0. Because remember the x-intercept, y-intercept. For x-intercept, we set y equals 0. For y-intercept, we set x equals 0, right? Okay, so the y-intercept in the context of a function is always f of 0, right? This one right here is always f of 0. And when you plug in 0 at the top, at the bottom, you get negative 10 over negative 18, which is 5 over 9, right? The y-intercept is 5 over 9, okay? Which is about 0.5, right? That is about the y-intercept. Everybody understand that? Now for the x-intercept now, is when y equals 0, which means I mean set y equals 0, right? Which means f of x equals 0, right? And when something is a fraction, when a fraction is equal to 0, who is actually going to be equal to 0, the numerator or the denominator?
Denominator.
The numerator.
No, don't rush to the answer. When you set a fraction equal to 0, right? It's going to translate to who equal to 0, the numerator or the denominator?
The numerator.
The numerator, because when you cross multiply, when you multiply both sides by the LCD, by the denominator, the right side will be still 0, right? So it's going to end up to be the numerator equal to 0, right? That is always the case. When you set a fraction equal to 0, it's going to be the numerator equal to 0, okay? So now the numerator is 5x squared minus 23x minus 10 equals 0. Why not you just use a quadratic formula, right? Maybe we can factor, but you see, maybe we can factor negative 50 and negative 25 and positive 2, maybe. Okay, let's try to factor 5x squared minus 25x plus 2x minus 10 equals 0. But you can also use quadratic formula also, right? Okay, which is 5x times x minus 5 plus 2 times x minus 5 equals 0. We get x minus 5 times 5x plus 2 equals 0. So we get the two x-intercept are 5, 0 and negative 2 over 5, 0, right? These are the two x-intercept. Obviously in the exam, I will not give you something with such big numbers, okay? Obviously. Because I don't want people to spend a lot of time just doing this. It's going to be something like, just like about what you saw in the test. We have 5 and negative 2 over 5. This is an x-intercept right here. And this is an x-intercept right here. So now, if you want to know how's the graph going to look like, okay? I repeat that again. So we don't know exactly how we can figure out some stuff, but in the case of the review, it's going to take us some time. We can know where the graph, when the graph approaches 3, when x gets close to 3, from the left or from the right, how the graph is, right? Okay, so by plugging in numbers, for instance, okay? For instance, when x gets too close to 3 from the right side, here, am I here or am I here? Okay, You can plug in a number that is close to, you see, what is my function f of x? F of x is x minus 5 times 5x plus 2 over 2 times x minus 3, x plus 3. That is my function f of x, right? When you plug in a number that is close to 3 from the right side, when you plug in, for instance, 4, right? F of 4, okay? What you get? You get 4 minus 5, which is negative, 5 times 4 plus 2, which is positive, over 2 times 4 minus 1, which is positive, 4 plus, which is positive. The end is going to end up to be negative sign, right? Since f of 4 is negative, so I say my graph actually is at the bottom right there. Now I can say, since we cannot cross asymptotes, I can guess my graph is like this. When you do calculus and you do what you call limits, you don't do no guess, right? And variations, increasing, decreasing, you don't do no guess. If I plug in a number right here, again, on the right side, am I here or am I here? To know that, let me plug in 2, f of 2. Where is the f of 2, right? If I plug in f of 2 in the function, f of 2, what I get 2 minus 5 is negative. 5 times 2 plus 2 is positive. 2 minus 3 is negative. And 2 plus 3 is positive. This ends up to be positive, right? So, which means here, my graph is actually up. So this one is, so I can guess this graph looks like this is going to come through the y-intercept and then the other x-intercept and then go this. I can get that, right? You see? So now, I'm not sure here. You see, for this part, I'm not sure for this part. I stop. I want to know, near this vertical asymptote, is my graph like this or my graph like this? Again, very easy to know. Plug in negative 2. Plug in negative 2 and see. F of negative 2. Negative 2 minus 5 is negative. 5 times negative 2 plus 2 is negative. Negative 2 minus 3 is negative. And negative 2 plus 3 is positive. So 3 negatives will be negative. So my graph is at the bottom, you see? Okay, etc., etc. But I would advise you, if you have a scientific calculator, a graphic calculator, I would advise you to use a graphic calculator to do that, right? So, but if you don't know how to graph actually, at least graph the asymptotes, okay? Graph the asymptotes, the vertical asymptote and the horizontal asymptote. I will not give a lot of points to that. For instance, if the whole question number 3 is 10 points, maybe maybe the graph will be about 1 point or 2 maximum, okay? The graphing itself. I'm more interested on somebody knowing how to find the asymptote, vertical asymptote, horizontal asymptote, x-intercept, y-intercept. I'm more interested in that, okay? All right, so that is the review for the rational function. Again, for the domain is about the denominator, not equal to 0. The vertical asymptote are very linked to the domain, right? Don't forget x equal. The horizontal asymptote, we compare the degrees, right? The x-intercept is a numerator equals 0, and the y-intercept is always f of 0. All right?
Hey, sir, please, I have a
Yes.
question.
Yes.
Okay. The question F, they said that to graph f of x using A and E.
Yes.
So now, if they say that, I think we don't have the vertical asymptote, no, horizontal asymptote in the graph, right?
Yeah. Yes, the horizontal asymptote, we're going to use the horizontal asymptote, etc. We're going to use the vertical asymptote, but this is really a stretch. Graphing in 163 is really a stretch because if the function is has some, we cannot, just like, graphing a polynomial. Do you remember the graphing of the polynomial? What we never be able to figure out in 163 is a local maximum, local minimum, right? So the graphing here, we just change about what is sketch the graph that's going to look like the real graph, okay? But we cannot really graph accurately. That is why, using the asymptotes, etc., don't get me wrong. In 163, we know how to figure out what is the behavior of the graph here, okay?
Yeah, I
All
got
right.
you. I'm not just talking about that. For equation F, they said that graph f of x using a and e.
No,
I'm just
not A and E, A2E.
Oh, okay.
That means
Okay.
2E. Yeah,
Okay.
that's why I didn't understand your question. Not only A and E, is A2E. A, B, C, D, E.
Okay, I got you.
Right. You have to use all the elements of the stuff, okay?
Okay.
But in the test, don't spend like 10 minutes trying to graph, okay? Okay, so point-wise, spend your time trying to find the domain, the x-intercept, y-intercept, horizontal asymptote, vertical asymptote. Graphing, at least, you put the asymptote, if somebody has a graphic calculator, it's going to help you out, but don't spend 20 minutes trying to graph, okay? It's going to waste your time, all right? All right, so now we can go over the next, if you go to the review, right here, so, all right, so for instance, we say, we give some like that, right? And some combination of functions, okay? Combination of functions. For instance, let me pick up this one. We will not do all of them. We just do some example of that, okay? Again, this is meant for somebody to review at home, okay? We cannot do all of them. So for instance, we say, let's say for instance, what is F circle G of 26? Okay, what is F circle G of 26? Do you guys remember what to do first? What you do first?
Write the f of x.
Plug in 26. You're gonna plug in 26 in what number? In what function?
G of x.
In G of x. First, we're gonna do G of 26, right? Which is square root of 1/2 times 26 plus 3 minus 9, right? That is 13 plus 3 is 16. 16 square root is 4. 4 minus 5 is a -5, right? 4 minus 9. Now, what you do next? Next, what you do?
Plug -5 into f of x.
Exactly. Put -5 in the f of x. Basically, it does this. It's like, two consecutive, no, not consecutive, successive actions, right? One action and then after another one. You do one action and then you do the other one, right? So now you do f of -5, you see, which is 3 over 2 times -5 plus 5, okay? All right, versus what? Versus, for instance, this. When you say p minus h of -3, do we have here an order of operations here? What you have to do first and then do next, do you have that?
I think we're gonna have p of -3
And then?
minus h of -3.
Yeah, and the two stuff are independent. You see, we don't wait until we calculate one and then to plug in on the other one. We don't wait for that, right? Here, we do two independent things. We do, on one hand, we do p of -3. On the other hand, we put h of -3, and then we subtract them. Okay? Okay, everybody? So don't confuse the composition of functions where you have to do a sequence of actions, right? You do one action and then do another action, right? Which depend on the other one, of the first one. Versus when you add functions or you subtract functions or you multiply functions or you divide functions, you do two independent actions, right? You do P of -3 on one hand, you do H of -2 on the other hand, and then you subtract them, okay? Everybody? All right, so now, go ahead. So now we say, what is F circle G of 20 of X now? We say, what F circle G of X? Now we have to plug in what function into what function?
What?
If we say F circle G of X, right here, if you ask this one, we have to do what? We have to
Plug
F
G into F.
X.
exactly plug G into F. Thank you. You have to take G, which is here, and plug into F right there. It's going to be F circle G of X is not a multiplication again. This is not a multiplication, right? Some people did do that. And remember, is F circle G of X is 3 over 2 parentheses, right? Because I have to put the whole function G square root of 1/2 X plus 3 minus 9 and then plus 5. Okay? So if I can reduce, if I can simplify, I can simplify. It's going to be 3 over 2 root of 1/2 X plus 3 minus 18, you see, plus 5 is minus 13. Okay? Okay, and then we can ask, okay, I'm going to, for the inverse of function, I'm going to give something which is more general. If I say f of x equal to -7x plus 3 over x minus 5, what is f minus 1 of x? You guys remember the steps we have to do? We have to set this equal to what?
To Y.
We have to set it equal to y, right? Now, some people, I guess if you follow Alex or stuff like that, some people do switch. You know, some people did write -7y plus 3 over y minus 5 equal x. This is the same thing. I like better this way, right? If you write this, what variable are you going to try to get by itself? At the end, if it was the first case, if you write this, what variable are you going to have by itself at the end? The x or the y?
X.
The x. And if you write this, you're going to try to fit the y. It's the same thing, right? So when we do that here, when we multiply both sides by x minus 5, cancel out, we get -7x plus 3 is equal to yx minus 5y, right? And then we could try to get all the x on one side. Let's say we subtract, we could move this one over here, this one over here. Get -7x minus yx equal to -3 minus 5y, right? And then comes the steps. Comes a step where you have to factor. Is x factor -7 minus y equal to -3 minus 5y. And then we divide, we get x equal to -3 minus 5y over -7 minus y. So now to write my answer, I say f minus 1 of x. Now I do the switch now. I say -3 minus 5x over -7 minus x. Okay? That was the thing in this topic. Okay, now comes this, where we have a piecewise function, you know, how to evaluate a piecewise function and then how to graph it. Okay, how to evaluate it and how to graph it. All right. Okay, so evaluate f of 9. what formula we use to evaluate at 9? The first one or the second one?
Second one.
The second one, right? So f of 9 is 4/3 times 9 plus 5, right? Which is, that's a lot, which is 12, which is 17, right? Okay. F of -7, which one are you going to use? The first one or the second one? You're going to use the first one, which is negative?
-3.
3. It doesn't change. If I say f of 3, which one are you going to use? The first one or the second one? F of 3. I mean, f of -3.
The second one.
If I say f of -3, I'm going to use the second one, which is 4/3 times -3 plus 5, which is 1, right? Etc., etc. So when you say graphic, now I have -3 is here. That is like my borderline, right? This is x equal -3. I will have two pieces of graphs. Neither of them will cross the line, right? Two pieces of graph, one on the left side, to the left side, one to the right side, and neither of them will cross the line. Neither one of them, okay? So the one which is easier to plug in is for the x's that are less than -3, okay? Which means the left side of -3. My function is just -3. It's going to be just like that. Okay. Now here at the very end, do I have an open circle or a closed circle?
Open circle.
Do I have this or should I have this? You said open circle, right?
Yeah.
Thank you. Because -3 is not included in this definition, right? Now to the right side, you see, this I have a straight line. I just need me a couple of points, right? I need me a couple of points to graph it. For instance, f of 0 is 5, right? F of -3 itself is 1, right? So f of 0 is 5. F of -3 is 1. This is my graph right there. Okay, so when you see something like that in your exam, think about this as graphing two lines, right? Separately. You are separately graphing two lines, okay? And that is you are in you are in 163. So obviously all of you know how to graph straight lines, right? So you have to think about it that way. You are separately graphing two lines. All right? Okay. So that is a piecewise function. Now, and next, what you can have next is, okay, graphing polynomials, right? So I mean, let's just pick one of them, you see, to graph, just to refresh memories. Just pick one of them. All right. So I'm going to use the zeros, okay? I already have the factorization form. This is zeros. And what are the type of zeros? The multiplicities, right? So hold on. I'm going to zeros first. I'm going to say multiplicity next. And there's type of zero next, right? What are the three zeros? Somebody tell me. What is the first zero you see here?
-9x.
-9x is a zero. What is the zero that correspond to it?
Zero.
I see.
It's 0, right? It's -9x equals 0, which means x equals 0, right? So you
And
have the
there's
0,
positive
0.
And then there's +5.
Then you have +5, thank you. And then you have, what's the last one?
-5/3.
-5/3. Remember, you have to set 3x plus 5 equals 0, and then you get x equal -5/3, right? Okay. Now we go to the multiplicities. What is the multiplicity of the 0, 0?
1.
1, because the power we see here on the top of the factor, the power 1 is the power 1. So this is 1. What is the multiplicity of the 0, 5? How many times this is a 0? Also
1.
1, right?
Yeah.
What is the multiplicity of the 0, -5/3?
2.
2.
Okay. Now the type, is it a cross point or a turning point? CP or TP? It is a parity, is about the parity of the multiplicity. If it is odd, it is a
Then
cross point,
cross
right?
point.
It's not a 0 itself, it's a multiplicity. It's not a 0 itself, right? So this is a cross point because the power, the exponent 1 is odd. This is also a cross point, and this is a turning point, right? Now I do my thingy, I do my this, right? So I have the 0, 0. I have the 0, 5. I have the 0, -5/3, which is about -1.6, right? Okay. At least I have to do one test. At least I have to test one interval, and then use whether they are cross point or they are turning point. At least I have to use one test. Let me test 6. What is f of 6? I get -9 times 6 times 6 minus 5 times 3 times 6 plus 5. How is it going to end up to be? Positive or negative? It ends up to be negative, right? Because -9 times 6 is -54, which is negative. 6 minus 5 is positive. The parentheses, the other parentheses also positive. So this is going to be negative, which means my graph first start by being below the x-axis, right? Now, since 5 is a cross point, my graph will cross actually, and then come down to 0. Since 0 is a cross point, my graph will keep crossing. It's going to cross and come down to this. Now, since this one is a turning point, my graph actually going to turn away, right? And do this. Now, again, something is very hard to know in 163 level is the maximum and minimum. This is hard to know, right? You see, how far we go up or how far we go down is hard to know. That is why we don't concentrate, we don't focus on that. That is why you're going to keep your y-axis unitless, okay? Don't put units on your y-axis. So you can justify this, okay? But the shape will look like this, all right? This is how we used to graph these polynomials. All right, right here. Number 7, right? Number 7, I think this was in our last test, you know. Okay, so look. What is the maximum number of zeros we can have?
5.
5.
4.
What is the degree here? It's 4, right? The maximum number of zeros here is only 4, right? 4 maximum zeros. Maybe it has 1, maybe it has 2, or At the most, it has 4. So now, what is the maximum number of turning points this one can have? Somebody remember what we said about that? Is it 4? Actually, the maximum number of turning points is 1 less the degree is 3. To the maximum, it will have 3 turning points maximum. List all the PRZs. We're just going to be the factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, divided by the factors of 1, which is plus or minus 1. So this is going to be only these right here, because we are just dividing them by 1. It's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, right? Is x minus 3 a factor of g? Explain. Is x minus 3 a factor of g? Can somebody answer to that question?
We have to verify.
We have to verify. Why we have to verify? Why we don't say yes or no?
Because it's PRZ.
Okay.
It is a PRZ, so we cannot say no, right? Because it's a potential. We cannot say yes until we verify. Thank you very much to both of you, right? So we have to verify, okay? If we say, if I replace minus, if I put x minus 7, is x minus 7 a 0, no, a factor, then we can say no, because you see, I saw in the last test, I saw this phrase right here. Can somebody tell me what's wrong in this sentence? Is this sentence? What is not clear? What is a little bit wrong in this sentence? Can somebody tell me? Oh, all of you agree with this way to answer? Nobody's
we
talking.
need it to be over 1.
All of you agree this way of wording your answer? There's something wrong in the answer.
Don't we need to have it be over 1 because it's the leading coefficient of the first degree?
Yeah. I mean, this is 7 right here. For sure, the 7 is not among the list. The 7 is not in the list for sure. It is not a 0 for sure. But this wording right here, what is wrong with this wording? Is it like a very proper wording? Because it is not a PRZ.
Are you talking about the number? You missed the number?
It's about that. If when I say a lot of you said it in the test. Why I bring it up? Because a lot of you said it. The it here, when you look, the it will
So you
replace
gotta
that.
say because x is not a PRZ.
Not the x, but the 7.
Oh,
Okay.
well, yeah, 7 is not the PRZ.
Exactly, because when you say it like this, the it is supposed to replace what? The whole factor, right? And a factor cannot be a PRZ. A factor is not a number, right? A factor is x minus 7, okay? You see, the whole expression x minus 7, it doesn't make sense to say it is not a PRZ, right? So that is why some of you now, I think 2 or 3 people said, because 7 is not a PRZ. You see that? I mean, so I didn't count it wrong, but just to let you know. Okay, now can we try to find all the zeros? You see, they didn't say find all the zeros, maybe for a reason. Maybe the zeros are very hard to find, right? Let me see if I have another example where they say find all the zeros. No, there is none, right? Okay, there is none. So right here, so if you're going to try to find all the zeros, right here, find all the zeros right here, right? No, this is just factor. No, it's not that. If you plug in numbers, for instance, if you plug in one, it doesn't work. 2 doesn't work. Let's plug in the negative numbers. Let's plug in -2 and see what happens, or -3. You have 1, 4, 2, -1, 6, right? 1, -2, 2, -4, -2, 4, 3, -6, 0. All right. So -2 works. You see, some of you in the last tests, they kept only checking the PRZs. If you just check PRZs at the best, you're gonna find the complex zeros. Is it guaranteed to find all the real zeros by just checking the PRZs? Is that a guarantee?
No.
Exactly. Thank you very much. If the square root of 3 is a 0, can you find square root of 3 by checking the PRZs?
No.
You cannot, because square root of 3 is not a rational number, right? You see, in the test, some of you just kept checking all these numbers. First of all, you're gonna write you're gonna do a lot of checkings, first of all, right? And second of all, you're gonna miss some zeros, probably, right? That is why, what is the algorithm? The algorithm says, every time you get a 0, you have to use a new one, right here. You have to use a new one, and then you check the zeros with this one. Now, what are the PRZs for this one? You see, now I have lesser PRZs. What are the PRZs? The new one has a less PRZs, is ±1, ±3. You see? Now, let me check -3. I put -3 here. I put 1, 2, -2, you know, and then I put 3 here. So I say 1, -3, -1, 3, which is 1 here, -3, 0. You see? -3 is a second 0. You see? You see now? If I go this way, and then at the end, I have a quadratic function, x squared minus x plus 1.
And then you can factor it and get your other x's, your other.
Exactly. You use a quadratic formula to get the other ones. The ones you will never be able to find checking the PRZs. I don't know how many people exactly did that. They just check the PRZs. They say you have, you know, the zeros are 1 and 2 in the test. No, you have 2 more. Okay? In the test, you have 4 zeros. Some of you just found 2 zeros because they just kept the PRZs. You have to, you know, you have to go this algorithm if you want to find all of them. You see? So now you say 1 plus or minus square root of 1 minus 4 divided by 2. You get 1 plus or minus I square root of 3 divided by 2. So what are my zeros? My zeros are -2, -3, and this right here. I have 4 zeros, okay? All right. Okay, so look, this one right here. Suppose the function h of t equals this, gives the height of an object in feet over time, in seconds. When does the object reach the highest point? When I see this question, and this is a quadratic function, right? This is a quadratic function. When I see the question, when is going to reach the highest point in the quadratic, in a parabola, right? The answer will be about what point? The answer will be about what point?
The vertex.
The answer will be about the vertex, right? You see, because I have a keyword here, the highest, this is a keyword, which means the maximum. And the answer is answer in the vertex. I'm not saying the whole vertex is the answer. I'm not saying that. The answer is in the vertex. Now, the vertex has 2 coordinates. It has an H, it has a K, right? This question right here, when the object will reach the highest point, is this the H or the K? Which one of them is the answer?
The K.
The K?
I think because when does the object reach the highest point?
When is going to reach the highest? When? I'm not saying what is the highest point. I'm saying when it's going to reach it. What is
Yeah,
what is the answer?
we have to find the we have to find the time, right?
Yes. What is the
So
time here? In this case, the time is it the H or the K here? In this case, is this
oh, it's the H.
as you know, here the vertex will be time and height, right?
Yeah.
So it's going to be the vertex will be like this: the time and the height.
Every time
When I
that
say when it's going to reach the highest point, the answer will be the time, right? Which is the H. And what is the H here? How we get the H? The answer is going to be always H is negative B over 2A. Okay? Which is negative 50 over negative 32, which is 50 over 32, right? Which is 25 over 16 seconds. The object will reach the highest height, the highest point up to 25 over 16 seconds, 1 point something seconds, right? Now, if there was another question that says, what is the highest value? What is the, what is the highest height? What is the maximum height? Then you're gonna plug in that number. You're gonna find H of that number, okay? If I understand that, this answer can be like very, very quick, very, 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 very quick to find. Now, when you say, when does the object hit the ground? When the object will hit the ground? At the ground, how much is the height?
0.
0, exactly. You see, at the ground here, the height is 0. So we say negative 16, this is a B right here. We solve negative 16t squared plus 50t plus 15 equals 0. We solve it, and the answer will be only the positive number, right? Remember, t should be greater than 0, right? In case you have these type of word problems, this is the same thing, this is quadratic function, etc. So now, transformation of functions right here. Let's just try to do this one, the E, because in the test I will give you something, probably something like the E. Let's try to do the E. Do you remember the transformations? At least the first 6 ones, shifting up, shifting down, to the right, to the left,
and right, and then
reflection on the x-axis, reflection on the, at least those 6. Do you remember them?
Yeah.
I don't think I will ask you about shrinking, stretching. I don't think so, right? I will not ask you about shrinking, stretching, but I will definitely ask you about this.
This
something
one
like that.
good, but I have I have a problem with the shrink, because when I have, for example, f of x, when they ask me to find f of 5x, it doesn't. I don't know why, but when I graph, it doesn't shrink the domain, and I don't know why.
Yeah, f of 5x. If you say f of 5x, this one is harder to graph in math, right? This one is harder to manipulate because the domain changes, right?
Yeah.
The domain shrinks 5 times. If
Yeah.
your domain was 0, 10, this domain will become 0, 2. In math, this transformation is more complex than the other transformation. You see, this one is more complex than this one. Because this one is just, you're gonna stretch the range. Here, you're gonna shrink the domain, okay? But I will not ask you about the stuff right here. I will just ask you about going up, going down, to the right, to the left, flipping over the x-axis, flipping over the y-axis. These 6 right here. For instance, here, this one, what you do for this one? F of negative x, how we flip it, over the x-axis or over the y-axis?
Over the x-axis.
You see, that was a guess. That was a guess. This is over the y-axis, okay?
Yeah.
Flip over y-axis. You have to review that, okay? When it's going to be flip over x-axis, when it is like this over x-axis. Okay, flip over x-axis. So now we have to flip over y-axis, which means everybody, you see this point come down, come here. This point comes here. This one comes here. This point comes here. So it's going to be like that, right? It's going to be like the y-axis will be like a mirror. This is going to be like that. Everybody agree with that? That is flipping over the y-axis. The y-axis is like a mirror to the graph. So now this one right here, how we move it?
Shift it up one.
Up one, right? So we move up one, so we have up one. So this one comes here. Okay, something like that, right? That's going to be the end. I would advise you in the test, I would advise you to do two separate graphs. If you have two transformations, I would advise you to do two separate graphs so you can have a partial credit if one of them is wrong, okay? I would advise you to do two separate ones in the test. All right, and then we have, okay, so this type of graphs right here, I mean, so look. I will not ask about compound interest, believe me. I will not about lines, you know, what is the equation of the line. I will not ask about that, right? I will not ask about binomial theorem. I could ask about this one, number 22. Okay, number 22. What is the domain? Can somebody tell me what is the domain of number 22? So let me copy it here.
Is it -5 to +1?
The domain is -5, +1, right? And you have to write it as an interval, right? Remember? You have to write it as an interval. You say -5, 1, and then both of them are closed. You do that, right? Because we have closed points. What is the range from what y to what y?
1, -4.
-4 to +4, right? Thank you. On which interval of x, f of x is decreasing? Going down, which means going down. -3 to 0, right? We say -3, 0. Here, it doesn't matter if, in this case, it doesn't matter if you open, you close, but we prefer to open the parentheses, right? In which interval of x is it increasing, going up?
-5 to -3, and then 0 to 1.
0 to 1, thank you. Right? Local maxima. You see, local maxima is the highest point, but inside the graph, not outside, not at the end, inside the graph. Local maxima is 4. Local maximum value is 4 right here. Local, right here, 4. A local minimum is this one right here. We don't count this one because this one is at the end. Is this one which is 0, right? You can also put the points. You can put the value of y, or you can put the point, right? You can put, you can say -3, -3, 4, or you can say here 0, 0, right? Please, these questions are not meant to be tricky. They are not. You know, you have just to remember the topic. There is no calculation. There is nothing, right? If you go over it, like, you know, a few minutes before the test, you know, you should be okay. All right. And of course, here, you know, find the vertex. You know, that was, I think, was it in the test number 3? Or it was in test number 2, right?
Yeah, it was in test number 2.
Test number 2. You know, if you go We talk about the vertex, how to find the vertex. You know, if you take this one for instance, you see, I mean, no, hold on. Why put this one, and this one is more calculations anyway, so why not put the other one? If you just want to remember the concept of it, why not put the other one? You see, further, you have 3 points or 4 points to figure out. The easiest one is we have the vertex here to figure out. We have the y-intercept, and we have the x-intercept. The vertex is easy, I mean, the y-intercept is easiest point to figure out. It's always f of 0. What is f of 0 here? Is 7, right? Y-intercept is 0, 7. That is y-intercept. The vertex, we do 2 steps. The first, we do negative b over 2a, which is negative 8 divided by 2, which is 4. And we plug in 4. We say f of 4 is what? Is 4 squared minus 8 times 4 plus 7. 16 minus, which is negative 16 plus 7, which is negative 9. So what is my vertex? Is 4, negative 9, right? The x-intercept, we solve x squared minus 8x plus 7 equals 0. This is x minus 1, x minus 7 equals 0. We get x equals 1, x equals 7. So 1, 0, 7, 0. These are the x-intercept, all right? And then I just put them on a graph. If you ask me to graph them, I just plot my points and graph, okay? If we talk about that. So now I will not ask you to identify graphs. I will not, right? You know, this is an absolute value function. Does look like it. This is like a cubic function. This one right here, number 2. Graph number 3 is like a rational function. Graph number 4 looks like an exponential function. Graph number 5 looks like a linear function. Graph number 6 looks like a square root function. Graph number 7 looks like a quadratic function. And this one looks like a square root function, etc. All right. That is the official review. I think between Tuesday and today, we did all the problems that will be relevant, right? On the stuff. You just go over it one more time. You have plenty of material that you can practice. You can practice our own test. You can practice the final exam. The final exam is just a regular test. It's just a regular test. If it was not for the percentage, it's only 20, you know, I mean, the final exam for your case is almost like a regular test because the percentage is only 20%. For the people in OED3, the final exam is 30%. That is a lot of, you know, lot of weight. But for your case, it's 20%, which is not you know, very, very different from 15% from a regular test. Now, the final exam, sometimes what make it a little bit tricky is the memory thing. It's like, you know, it's going to touch like chapter 1, chapter 2, chapter 3, chapter 4. But it's not about the level. It's not about how hard it is. It is not harder than all the exams we did. It is not. It's just, do you remember enough, right? Okay. So I did, the test will be, you know, I did an announcement for the test. When the test is going to be, check out your syllabus. I think I said test is going to be, exam date is going to be December the 16th, which is Thursday, right?
Right, Thursday.
12 to 2. It's not 12:45. Yeah, don't come like 12:45. If you come 12:45, you are missing how many minutes? You are missing 45 minutes because I will not stay, okay? I have some other stuff to do. So you have to, it is your responsibility to check the date and the time. We did enough announcement. It is on Brightspace. It is in your syllabus from the beginning of the semester. So you cannot come like 45 minutes later, okay? It's gonna be 2 hours. It's like about 12, 13 questions. It's not like, you know, you will have plenty of time to do them. All right. So the project, I will grade the project like in the next couple of days. And then I will put it, you know, when I look at it, a lot of people, at least presentation wise, a lot of people did a good job, you know, even those people who did the handwriting, it was nice, right? That's good. Now something, you know, I just throw it like this, you know, I'm not saying, but nowadays we have to pay attention to the ways, because as much as we try to develop technology, there is a bad direction the technology is taking on for the students, is the cheating direction. You know, and you guys know what I'm talking about. Nowadays, you have some website, some professional website where you can find everything. You know, you can find like the teacher's test. You know, as the students can be aware of that, the teacher is also aware of that. Okay, so if the project is given somewhere, solved somewhere in the net, and you just go ahead and you take it from there, you are cheating. That is like cheating. If somebody can make the case, the consequences can be, at least for your, you know, for somebody's semester or somebody, you know, education, the consequences can be hard. So my advice would be, the tools of cheating are more and more developed. But if somebody really want to be serious about, you know, about having an education, don't go there. That is just my advice. And the day is going to catch up to somebody. If we, you know, if we catch somebody cheating, I'm not inventing. CCBC or another university, they are very tough about that. You know, basically the rules are very tough. Okay, if we can make the case this student has cheated, if we can make that case, the rules are very tough. Okay, and we can make that case, you know, because math is math. So my advice would be, the project, even if maybe the project is solved somewhere, I'm sure of that. Okay, but still, if somebody just go ahead and take the official answer key that is of the project inside, and as a grader, I can know that, you know, it's, you know, because I know where to go to get it. So don't, you know, that's my advice, okay, for everything from this semester and other semesters, etc., etc. That is my advice. All right, so your class was a good class, you know, to teach. And I wish good luck to everybody. So when, after we do the test, we do everything, when you see your grade, that is the maximum grade you can have from me, because I don't undergrade students. I don't undergrade. That's just my nature. I do not undergrade. So if somebody got a grade, that is the maximum grade they can have from me. Okay. So I go pick up I want to grade the project, pick up the Alex, you know, the Alex grade. I just go and pick it up, put everything together, and then after we do the final exam, that's going to be your grade. I wish good luck to everybody. You have my email. You can email me, right? If you need, you know, help, stuff like that. All right, everybody.
Are we here on Tuesday?
I mean, the test is when is we test the
Thursday.
final exam. It's Thursday, so we don't have, no. This is our last class.
Okay. Okay.
Yes, this is our last class, and the next time you're gonna meet is gonna be for the
Sir, please, I have a question.
Yes.
Okay, to find.
Carlos, Carlos, hold on a second. Carlos, you hold on a second after the class. I need to talk to you. Yes.
Okay, to find the interval where the function is increasing or decreasing.
Yes.
It doesn't matter if we close or open the interval, because I just saw that here you open the interval. I just was wondering if it's not a problem.
No, it's not a problem, especially when I'm grading. Now, if you are doing if you are doing some online stuff, you put an open interval, and they're not happy about it, you put you close them. If you close them, but in general, mathematically talking, for the rigorous answer in math, we open it, because at those points, exactly the derivative is 0. You see, and when the derivative is 0, it does not increase, it does not decrease, it does not decrease. Usually at those points, you know, the turning points where the variation of the function changes from increasing to decreasing, the turning point, usually they are called critical points, critical numbers, where the derivative usually is 0 sometimes. And when the derivative is exactly 0, it does not increase, it does not decrease, it is constant at that point, That is why, to be more rigorous, we open it.
Okay. Thank you.
You're welcome.
Okay.
All right. So